Going on now to a practice test of Chapter 4. You recall that 4 is a combination of systems of linear equations and then going into exponents. So let's start in the beginning with example 1 here. And the protocol again will be to have you copy the example down and give it a try on your own. So one of the first things you want to do is, after you copied it down, is to look at it carefully and see which method should I use to solve it. Now as we look at this one, we notice the y's are the same terms, but they're both pluses. But if for some reason we could modify this positive 5y to a negative 5y, and then I added these together, the y's would cancel out. So I'm going to do that by multiplying every term in this equation by a negative 1. So as I multiply this by a negative 1, and I'll change colors here so we can see it, this will become a negative 7, and this will become a negative 5, and this will become a negative 25. So now as I add them up, this is a negative 4x. Here these cancel out, and this will be a negative 20. So now, to solve for the letter x, I'm going to divide this by a negative 4, this by a negative 4, and I get x equals a positive 5. So I have one member of my ordered pair now, as x is a positive 5. Now I still need to find what the y value is. And for this I can go into either equation. I know now that x is 5. So 3 times 5 is 15 plus 5y equals 5. I'm going to transpose the 15 to the other side. Becomes a negative 15 and a 5 is a negative 10. And I have 5y equals negative 10. Divide both sides by 5. I get y is a negative 2. Now, if I were doing this on a test, I would take these values, put them in these equations, and then check to see that they are in fact a solution for both of them. And they are. Okay, we're going to do the same thing for number 2. Take a moment, write it out, and we'll look to see what can be done to eliminate one of the letters or to use substitution, whichever method. So we've written out the examples, and generally over on the left side of your paper, and we're studying them. Now, just by changing the signs, nothing's going to cancel out. But if this were a negative 4x here, these would cancel out. So I'm going to have to modify this equation And I'm showing you a technique to do it, so if I ever look at it, I can give you partial credit showing the correct procedure to solve something like this. In this second equation, I'm going to multiply every term by a -2. Now I just copy this one straight ahead here. 4x minus 7y equals 6. Now I'm going to multiply this. -2 times 2x is a -4x. See, this is what I wanted to do. -2 times a -5y is a positive 10y. And -2 times 12 is a -24. And you should always check your work. Okay, that looks good. Now I can add these up. I cross those out. This just is a 0 here. This will be a 3y. And this is going to be a -18. Now we're going to divide both sides by 3. I get y equals a -6. So there's one of my ordered pair members now. And I can go to either equation. Let's use this one here. So I have 2x minus, so a -5 times a -6 is going to be a positive 30 equals 12. I've taken my value for y, substituted it here, did this multiplication, I get this. Now I'm going to subtract 30 from both sides, and I get 18, a -18, and then I have 2x equals a -18. So on this side, the 30 becomes a -18, I'm sorry, -30, I get this. Now I'm going to divide everything by 2. I get x equals -9. And again, you could take these, put them in these equations, and see if they make the statements true. And I did do that, and they do check. All right, we'll move it up a little. Now, for number 3, we're jumping into applications. Again, pause it, read it, and see if you can come up with 2 equations using 2 variables. I would suggest you use M for males, F for females, and pause. So, males plus females, total of 27, and the males equal the female number less 9. So again, as you study this, you wonder, what method can I use to solve it? And I believe the answer would be substitution. That if you take m as equal to f minus 9, put that in this equation, so we get m is going to be f minus 9, this is the m here, and then plus f equals 27. And then we collect like terms, 2f. Transpose this to the other side is 36. Negative 9, add 9, 36. F is 18. Well, if F is 18 here, 18 minus 9 is 9. So there are 9 males and 18 females as an answer for number 3. So this wasn't too bad. Okay, as we look at example 4, again, you're going to have to read that carefully. Pause it. And as we start to lay out the equation, we have 2 plans. On Wednesday, there were 8 that used plan A, and 3 that used plan B, and on Wednesday they spent 7 hours. And on Thursday, there were 2 that used plan A, and 5 that used plan B, and they spent 6 hours. So, that wasn't too bad in kind of organizing your data into your equations. But now you get to the next step. What do I do to solve this? Well, again, looking at this one, if I multiplied this equation by a negative 4, if you're thinking that already, so that this becomes a negative 8a. So again, putting that on the left, and now you're just copying this equation. Sometimes you may need to modify both equations, but so far we only had to do one. So this will be a negative 8a. This will be a negative 20b. And this is going to be a negative 24. Now, as we add these up to eliminate one of the variables, this is 0. This is a negative 17b. Adding this up is a negative 17. So if I divide by a negative 17, I get b equals 1. So we now know that the B version takes 1 hour. Now, if B is 1, I can use either of these equations, and I'm over here. I can use this one. So 5 times 1 is 5. So I have 2a plus 5 equals 6. Because our value of b is 1. 5 times 1 is 5. I subtract 5 from both sides, and I get a 1 here. 2a is that. Divide both sides by 2. I get a equals 1/2 hour, and b is 1 hour, and that is correct. All right, we're looking at number 5 now. Again, pause it. You want to see if you can come up with a set of equations that represents this data, so that we can work here a little bit together in regard to letters. Let's say the advance ticket would be A, and the same-day ticket would be S. Okay? So we know then that the sum of these, this is the price of the advance ticket. This is the price of the same day ticket. And the cost of these together is going to be $75. That'll be my hint. And let's see what happens. So then we know that A plus S is 75. And we sold 25 advance tickets and 40 same-day tickets, and the total amount of money taken in was $2,400. So then our next step is, what method are we going to use to solve this? Now, since we used elimination a couple of times, let's use substitution again, because we can say that A equals 75 minus S. Just transpose that. So wherever there is an A, we put that in. And let's do that here. So 25 times A, which we said is 75 minus S, plus 40S equals 2,400. So I need to use my calculator to do some calculation, and hopefully that's what you're doing too. So when I did this multiplication, I got 1875, a negative 25S, and the rest is the same. I group like terms, I got 15S here. I subtracted this from both sides, I got 525. Divided both sides by 15, I get the same day tickets worth $35. And if I subtract 35 from 75, the advance tickets were $40. Now, by getting an advance ticket, you're paying a little bit more, but you're sure to get a seat. I'm sure the same-day tickets could sell out and you may not get one. And again, whatever the strategy is. Often they have advance tickets or less. At the door would be more, but that was what the problem was. Okay, let's go on. Now in example 6, we're asked to graph this inequality. And we know that when it looks like this, we could also write it y equals 1/2 x minus 2. So we then have to determine, when it's an inequality, what kind of line are we going to use to draw this graph? Will it be a solid line, or would it be a dotted line? And you have that choice. Well, if it's greater than or equal to, if the equal to is there, along with the inequality, then it's a solid line. So let's just graph this. So this is a -2 on our y-intercept. Our slope is 1/2. So that means we're going to go over 2, up 1. And I can put in some more points, over 2, up 1. There's my x-intercept, over 2, up 1. So this will be my line here. Now, in an inequality, we also have to determine where do we shade, because it's not just answers along the line, but it's a whole region of possible solutions. So remember, we had said that if we have a positive y is greater, then we're going to shade above the line. But we also had a test where we could put in this, let's say the origin, that's 0, 0, and see if this is then true. And we're going to put here a 0 for the y. is greater than, a 0 for the x makes this 0, a negative 2. Now, is 0 greater than a negative 2? And that is true. So we did shade in the right place. This trial point here is in the area of solution. Now, if you did another point down here and put that in there, that would not be a true statement. So this is not the area. Here is the area. Okay. Now we'll have a few short answers and just review technique. Now in parentheses we have a negative 9 raised to the third power. So we said anytime a negative value within parentheses is raised to the third power, the answer is going to be a negative something. And just 9 to the third is 729. Now, within a parentheses, a negative value raised to an even power is always going to be positive. So 6 squared is 36. Now, as we look at number 8, and again, pause it to see if you could get the answer. Whatever our answer is going to be, it's going to be negative, because that negative is outside. Now we're going to square 1, and that gives us 1. And we're going to square 5, and that gives us 25. Now here we're going to cube 5. 5 times 5 times 5 is 125. And 2 is not cubed here. That's over 2. So we've just simplified things here. Now as we start to do some multiplication, we get 8 times a negative 2 will be a negative 16. Negative times a positive. And then we get u, remember, is to the first power, times u to the sixth power. In this case, we just add exponents, and we get u to the seventh power. Going on to number 10 now, we're looking at the power rule, where something in a parentheses is raised to a power that has a power already. Here we multiply. So in a sense, this is written 4 times. So 2 times 4 is w to the 8th power. All right, now here, for number 11, you need to be familiar with the formula for compounded interest, not simple interest. So the formula for compounded interest is future amounts is equal, or future value is equal to the principal, which is the 35,000, and the formula is 1 plus the rate, which is in its decimal form, raised to the time, and this is in years. So if we put here 35,000, or I should say 3,500, 1 plus this is going to be 1.09 raised to the first power. You should try this on your calculator. That would give you this answer. And then 3,500. This is the same. But now we're going to square this, because it's 2 years. So the deal would be you do this part first, then multiply it by this. Since this is the first, it's just going to be this times this. Try that out. Pause it, because I'm going to give you the answers here, and you can check it. So this would be 3,815. And this is 44,158.35. Okay, so they are asking us to do things like this. And again, I'm hoping that you can remember this formula. It's pretty straightforward. Now, these next few are pretty straightforward. Anything to the 0 power is 1. So 6 to the 0 power is 1. Now, again, anything to the 0 power, but the only thing to the 0 power is what's in parentheses here. So all of this just becomes 1. And then we go 2 times 1 is 2. Now here they're asking us to write this without exponents. We can convert the negative exponent to a positive exponent just by moving this down to the denominator. Crossing, remember everything is over 1, crossing the division bar, the sign of the exponent changes. And then this will be 1 over negative 2 times negative 2 is a positive 4. Now they're asking us to write this in standard notation as a normal number. Well, we start to write it. Let me see here. I don't know where I'm getting a 2 from. 9, 7, 5. And what this says is we need to move the decimal place 5 places to the right. So we move it 2, then we have to add 3 zeros. And then with our new decimal point here, and I guess I can erase this one here, there is this in scientific notation written in standard notation. Now we had some rather challenging examples in the beginning, but now these are easier. We want to simplify this, and my strong suggestion is to put it in vertical like columns, like term columns. Now there is no x to the first, so I'm going to just put a placeholder there. And this is plus 6. So I just added a value here that has no value. 0x has no value. Just occupies that place. But now we have a parenthesis with a negative sign in front. So this is subtraction. Now the rule for subtraction like this, you can think of a 1 being there, and you're going to multiply each of these terms by a negative 1, which reverses the sign. Or just remove the parenthesis and change the signs. I like the idea of multiplying through, but the other one's good too. So this is a negative 1x now. We don't usually write the 1, but you can. This becomes a positive 7x, and this will become a negative 5. So adding these up, this is 3x squared plus 7x plus 1. All right, not too bad. Now, we are asked to multiply this binomial, that is, square a binomial. And we did give you a special technique, and let's just review. A plus B, quantity squared. Well, we said this can be done in 2 ways. It could be done by writing it twice, and then foiling first gives us a squared. Outers give us a plus AB, inners a plus AB, and then last a plus B squared. And we have like terms in the middle that are identical, so we get A squared plus 2AB plus B squared. And we call this a perfect square trinomial. Now the shortcut method that you're going to need in Math 1108 is you square this first term, that gives you A squared. You multiply these two together, that gives you an AB. But now you double it, so you get 2AB. And then you square this term, and that gives you a B squared. And you'll notice the answers are the same. Now here we're going to use the FOIL, first terms. Again, you can try it, x squared. Outers, a positive 5xc. Inners, a positive 7xz. And then last, a positive 35 c squared. Then we have like terms in the middle, so this is x squared plus 12xz plus 35 c squared. For number 18, again, we're just multiplying this by this. Negative 5 times negative 4 is a positive 20. W to the third times W to the second, we just add exponents. W to the fifth. Okay, let's raise it up. We're almost finished now. Now for number 19, we want to recognize what we have here. That these are the product of the sum and difference of the same terms. When you see something like this, the terms are the same, but one's a plus, one's a minus. These are called conjugates. And the rule we said was A plus B times A minus B. These are conjugates. So when you multiply conjugates, FOIL them, you get A squared minus AB plus AB and then minus B squared. Well, when you multiply conjugates, the middle terms cancel each other out. So you end up with A squared minus B squared. So here, if you recognize that these are conjugates, this is going to be 49 U squared minus 36 W squared. That is the difference of perfect squares. The difference of perfect squares. All right, our last one is to divide this, and a way to set it up, since it's only a monomial, is 8u squared plus 36 divided by 4u. But the way we suggest is you put the 4u under each term. And now you can simplify this as to 2u, and this, the 4 goes into the 36 9 times, but there's a u left in the denominator. Okay, for some reason all our tests are coming out to be about 35 or 36 minutes here, so hopefully this is a good review and helps you get ready for your test.